All right, welcome to The Explainer. Today, we're diving into a paper that's a real game changer for how we build smart AI. We're talking about a massive shift from having to spoon feed a machine what's good to actually letting it figure that out all on its own. So, let's start with a question that sounds simple but is actually incredibly tough. How do you teach a robot what good even means? I mean, think about it. If you've got a robot arm, how do you tell it, hey, that was a good job? This right here has been one of the biggest roadblocks for AI researchers for years. For us humans, learning is pretty straightforward. We get instructions, we get feedback, we watch others. But for a lot of these advanced AIs, it's a totally different ballgame. They mostly learn by just trying stuff, trial and error. And the only thing guiding them is this system of rewards. You can basically think of them as digital doggy treats for when they get something right. Okay, so we're giving the AI digital treats. Simple, right? Well, not so fast. This whole idea of a reward is where things start to get really, really tricky. The whole thing is built on this idea called the reward maximization principle. And the paper has this great analogy. Think of a monkey learning to do tricks to get bananas. The more bananas, the better. Well, an AI does the exact same thing, but for digital points. It's constantly trying to rack up the highest score possible. And that simple drive, that hunger for more points, is what pushes it to develop all these complex skills, like perception and adaptation. It's what makes it intelligent. So, you can see this reward system is literally the engine that powers AI learning. But here's the problem, and it's a big one. Designing that engine correctly has been a massive, frustrating bottleneck for pretty much as long as AI has been around. And at the core of that engine is something called the reward function. This is the rulebook. It's the set of instructions that tells the AI, okay, doing this gets you 10 points, but doing that will cost you 5. It's how we define what the AI should care about. And for the longest time, how did we create this rulebook? The hard way. A human expert would literally sit there, watch what needed to be done, and try to write down some rules. Then they'd let the AI try, watch it fail miserably, and go back to the drawing board to tweak the rules, over and over and over again. It's as painful as it sounds. Yeah, this manual way of doing things is just bad. It's slow, it costs a fortune, and worst of all, it leads to some really weird results. The paper talks about something called reward hacking. This is where the AI gets super clever and finds a loophole to get the reward without doing the actual work. The analogy of a kid shoving toys under the bed to clean the room is perfect. The AI gets its points, but the job isn't really done. Okay, so that's the old, broken way. Now let's get to the really cool part. The breakthrough in this paper basically takes that entire model and just flips it completely on its head. The central idea is so powerful because it's so simple. What if, instead of us humans trying to guess the perfect rulebook, the AI could just figure it out on its own? What if it could look at everything it's done before, all the successes, all the failures, and discover the best possible reward system by itself? So how do they do it? They came up with this really smart system called a bi-level optimization framework. Now that sounds complicated, but the best way to picture it is a team with a coach and a player. And the cool part is, they're both learning and getting better together at the same time. And this is how that team works. Check out this feedback loop. First, you have the coach, that's the upper level, and it comes up with a new set of rules for the game. Then, the player, the lower level, takes those rules and tries its best to win. The coach watches how the player does, analyzes its performance, and then uses that information to make the rule book even better. And they just keep doing this over and over. So the rules get smarter and the player gets better all at once. And the result? It's night and day. Just look at this. On the left, you've got the old way. A poorly designed reward has the AI just wandering around, totally confused. It's lost. But on the right, with the new discovered reward, it's like a laser beam. The AI knows exactly where to go, what the best move is, and it just goes for it. No hesitation. Okay, that's the theory. And it sounds amazing. But the million-dollar question is, does it actually work in the real world? Let's dig into the results the researchers published. And they really put this thing through its paces. They didn't just test it on some simple toy problems. We're talking challenging simulations, complex robotics, and even messy real-world industrial tasks. Just take a look at these results from the robotics tests.
They were trying to get a simulated humanoid to walk. That thing has 17 joints, so it's incredibly complex. That orange bar on the right, that's the AI using the reward it discovered for itself. It's not just a little better, it's crushing the performance of the reward designed by human experts. The AI basically taught itself a superior way to learn. And what's so cool is how it did this. The system automatically figured out what the most critical moments of the task were. It learned, all by itself, to give a massive reward for success and a big penalty for failure. It learned to focus on what actually matters, something humans really struggle to program in by hand.
Okay, now for a jaw-dropper from the real world. They applied this to managing the cooling system for a massive data center. This is a super complex, high-stakes job where every bit of energy saved matters. The AI agents using this new framework cut energy use by more than 60%. That's not just a small tweak. That is a huge, tangible impact on the bottom line. And they didn't stop there. They tried it on an autonomous drone. And again, the results speak for themselves. The drone, using the self-discovered reward, that's the orange bar again, hit way more of its target waypoints. It just flew better. It was more stable, more reliable, and more successful. So the bottom line from all these tests is pretty clear. This isn't just a small step forward. This method creates a much more robust and successful learning process. It helps the AI find a clear path to its goal, especially in those really tricky situations where the old school methods would just give up. All right, so we've seen the tech and the results. Now let's pull back and think about the big picture. What does something like this really mean for the future of AI? Here's the key takeaway. That whole painful process of designing rewards, it's been a roadblock holding AI back for decades. By automating it, by letting the AI find its own way, this research is basically clearing a massive obstacle off the road towards truly general-purpose adaptable AI. We're talking about the path to things like embodied AI, and maybe even artificial general intelligence, or AGI. And listen, the researchers themselves are not shy about the implications. They literally call this a significant milestone and a direct pathway toward understanding and building AGI. So in their view, this isn't just another small step. This is a potential turning point for the entire field. And that really leaves us with a fascinating thought to chew on. For decades, we've been trying to force our own motivations onto machines. But if an AI can now start to discover its own motivation, what does that open up? What's the next frontier when the machine itself helps write the rules?